Yeah, so we talked about exponents. So now I'm going to, so based on whatever we had over there, like how do powers deal with each other, I want to give you some challenging questions. So spend a couple of minutes on that. I'm going to show you some examples and then obviously we'll work it out. So for example, this one. Now this is equal to y. Then the question says that find the value of 3 power x. Now here's the thing. We usually look at the product rule in a way that, okay, if I have 3 power x times 3 power y, then the powers will add. That is something we already know. But we can also think of it like this. If I have powers that are added, then that means they're multiplying. So while we all easily think in this direction, we should be able to think in this direction as well. The backward side is important because it's still the same thing. It's still that equal sign. And that is why this one, you can split it and you can make it 3 power x times 3 power 2 equals to y. So what does that mean 3 power x is? That is times 9 equals to y. And that means what is 3 power x? 3 power x is y over 9. There you go. And that's my answer. Now the SAT people know this. So that is why they design questions in a way that it's not really that, all right, you have 3 power 7 divided by 3 power 4. Because everybody knows you can just subtract the powers. But they will give you something like 3 power x minus y, and then you have to go back. So this backward integration is important. Okay, let's try another one.
Sir, sir, the 3 raised to the power 7 divided by 3 raised to the power 4,
Yeah.
doesn't the 3 get divided by 3 as well?
No, because this whole number is divided by this whole number. The power is not separate from the number. Okay. Similarly, what they'll do is that, for example, we know that, okay, here's the question. 3 power a plus 1 is equal to 3 power 7 minus a. So find the value of a. Now it's a pretty straightforward question that because this number is same as this number, that means the power will equal to this power. So we can say that this implies that a plus 1 is equal to 7 minus a. And so a plus a equals to 7 minus 1. Basically, I move this here and move this here. And that means 2a is equal to 6 and a is equal to 3. But here's one thing that they'll do. Instead of giving you a question like this, everybody's comfortable with 7 minus a. But what is uncomfortable is if instead of writing 7 minus a, they write minus a plus 7. And now people will find it slightly difficult to do it, even though it's technically the same thing, right? So just remember, if you have something like this and it makes you uncomfortable, rearrange it. Write this as 7 minus a. Put the minus thing at the end. And we can do that, right? Sorry. So there you go. A is equal to 3. Now, what are we doing? The idea here is that if the base, this number is same, then the power should also be the same. Similarly, in SAT, sometimes they give you a question like this. 3 power x minus 3 is equal to 5, then what is 3 power x? So now what you have to know is that, wait a minute, I know that when numbers divide, the powers subtract. So if the powers subtract, the numbers are dividing. So this means this is 3 power x over 3 power 3. The numbers are dividing. But sometimes what they do is instead of writing the same thing, they'll present it like this: minus 3 plus x equal to 5. And now you're like, wait a minute, how do I subtract this? So don't worry about it. It is still the same thing. Rewrite it. And now you know what to do. Okay. If you're not comfortable directly with this. So that is one thing that SAT people sometimes do. All right, let's try another one. Another thing that they do is they disguise a number as some other base. For example, if they say, now this is a question that many people struggled with when it was first asked, that if 2a minus b is equal to 4, what is 4a over 2b? Now, the problem with this question is that you read the first part and you're like, okay, that's right, I can work with it. And then you're like, what? There's no relation there. It doesn't seem like there's a relation of this thing with this thing. But technically, actually, there is. Because what you should do is look at this thing and see if you can simplify it. And you can simplify it. Okay. So this is 4 is 2 squared. And what does that mean? This is 2 power 2a over 2b. which is what? 2 power 2b minus a. And that is something we have already seen. So if the connection is not that apparent, maybe simplify it and the connection will be apparent. So now this thing becomes 2 power 4, which is equal to 16, and that's your answer. Work these these steps out. It's important that you do. Now, today, any questions so far?
So I didn't get this last step you did where you converted it to 16.
I'll start over. So I'll start here. This was the question, 4 power a over 2 power b. And what they told me was 2a minus b is equal to 4. But turns out I do not see a connection of this thing with the question itself. So what I did is that I first broke it down. I know what 4 is. This is 4 power a, and 4 is 2 squared. That means it is 2 squared power a. And then power upon a power multiplies. We know that. That is a rule of indices. So power upon a power multiplies. So this becomes 2 power 2a over 2 power b. And now this thing becomes 2 power 2a minus b. Why? Because if the bases are same and the numbers are dividing, powers will subtract. And there I know what that is. 2a minus b, they've already told me it is equal to 4. So I just plug that in there and that makes it 16.
Yeah, I got an answer. Thank you.
Great. Now, the next thing I want to focus on today is surds. Surds are basically this symbol. And this symbol is basically division in power. That's what it means. In exponent, when you divide things, that's what surd are. Now, for example, I have this thing, square root x. Now, what this means is that basically the power of the number inside, 1, for example, is being divided by 2. If there's no number written here, then it is 2. Okay. If I have this of this thing, that means the power inside is divided by the number outside. Okay. So that's what it means. So for example, if I have x power 4 over 3, I can write it as x power 4 divided by 3. So the reason this looks like a division sign is because it is a division sign, but it's just the division in power. So for example, if I have this thing and I need to simplify this, what is it? It's simply divide the power by 4. There you go. Okay. And this thing can be called 4th root as well. And that's fine. Just write it like that. They don't ask you to tell what it means. But how do we simplify this? Now, here's the thing. X power 5, try to break it down into this. So what's the nearest number to 5 that divides by 4? 4 itself, right? So x power 4, the x power 5 can be broken into x power 4 times x power 1. So now, what does it make? It means I can divide this x power 4 by 4 on the outside. So it's x power 4 over 4 times x power 1 over 4. So this becomes x power 1. And what is that? That is still x power 1 over 4, which basically means that you can divide surds. You can break surds into multiple parts. So I can write this portion as x power 4, 4 and x power 1. And this thing now becomes x. Why? Because the power inside and outside cancel out. And you're left with this thing. And that's the simplified form of this. Let me try this one more time. What if they told us that we have to find square root of 96? Now, I know that 96 is, what is 96? 16 times something? Is that what 96 is? Can you divide this by 16? Yeah, 16 times 6. So 96 is 16 times 6. Now, do I know square root of 16?
Yeah, 4.
4. So that means I can divide this into this, which means this becomes 4 square root of 6. I don't know the square root of 6. And that's it. That's my simplified answer. Now let me try this, the same answer, but what if they gave us square root of 96 and instead of giving square root, they gave us 3 over here. Now let me break 96 into some other number now. And for that, I'll use a ladder method. There are 2 ways of doing this. One is ladder method. Ladder method says that you pick any number that you have, the prime numbers to be exact. So this you divide. 2 4s are 8 and 2 8s are 16. So basically I have half 96. Half of 96 is 48. Half of 48 is 24. Half of 24 is 12. Half of 12 is 6, half of 6 is 3, and 3 obviously divides by 1. So this thing I can write it as, how many 2's do I have? 1, 2, 3, 4, 5. So this is 2 power 5 times 3, and the 3 outside remains. Now, I can't really do it right away for now. What I'll have to do is I will have to split this number as well. Split it in a way that you can divide by 3. So how do you split 5 in terms of 3? You
2
can
raised
divide
to
that
power
3 and 2,
3. Yes.
right? Yeah. And now this thing you can divide. 2 power 3 divided by 3 is 2 power 1. The rest of it you can't divide. So that just stays inside. So that is 4 times 3, that is 12. So that's my final answer. So I can say that cube root of 96 is 2 cube root of 12.
So can you give us one of these to practice ourselves?
Yeah, sure. Go on. Let's keep it simple. Try to solve this thing, 81. It's a really simple question.
Sir, the final answer is 3 raised to the power 3 goes outside of the square root box, and cube root stays outside as well, and then inside there's just going to be 3 raised to the power 1.
Good, that is right. So here's one way to do it. So the method is that you break it down. This is 3 power 4, which if you further break it down, it becomes 3 power 3 and 3 power 1, right? And
Yeah.
I think that's what you're doing. So this 3 divides, you're left with 3 power 1, and this thing stays inside. So that's the final answer.
ये रखा है मैंने.
Perfect, perfect. That is the final answer.
Sir, is the final answer 2 cube into 3 squared?
2 cube and 3 squared. That is what 72 is, but that's not the final answer.
लेकिन सर आपने अंडर रूट के नीचे कुछ लिखा ही नहीं है.
नहीं, the square root, when nothing is shown, that means it's 0.
I don't follow.
So basically, if there's nothing written over here, that means it is 2.
So, sir, the final answer is going to be 3 is going to be outside of the box.
Yeah.
Square is also going to be right where it is, and inside the square root there's going to be 2 cube.
We can still simplify that. So for example, this thing, you can write this as 2 cubed times 3 squared. How did I know what to write? Basically, I know that 72 is 8 times 9, right? That means it is 2 cubed times 3 squared. Now I can split this cube into 2 squared and 2 power 1, and that 3 squared remains. And now I'll divide the powers. I'll break it down now. This portion, when 2 divided by 2 is 2 power 1, goes outside. This portion, 3 divided by 2, 2 divided by 2, that's again 3, it goes outside. And whatever is left inside, 2. So my answer is 6 square root 2. Basically, once you have simplified everything, you've broken down everything, you have to make sure that whatever power you have here is divided by whatever number you have here. If the number is not written, that means it is what you call 2. Okay.
चलिए आखिरी part जरा एक और दफा समझा दें.
आखिरी part, which part? Can you tell me which step?
Like the extra simplifying part, because I simplified it like इतना ज़्यादा नहीं किया मैंने simplify.
Okay. मैं यहाँ से दोबारा कराता हूँ.
जी.
ठीक है. So here's the thing. 8 is 2 cube. I split this 2 cube into 2 squared and 2 power 1. Why? Because I have 2 on the outside. So I have to make it in a way that it divides by 2. And that is 3 squared. Okay. So now I have powers that divide by 2. So this power divided by 2 leaves me just 2 power 1. Okay. Because 2 divided by 2. This power divided by 2 leaves me with 3 power 1. But this power does not. So it stays inside. And my answer is 6 square root 2. You get it?
Yeah, thank you.
Try another one. Let's say 48 and you have 4 here.
I'm inside the box. I'm getting 2 raised to the power 4 into 3 raised to the power 1. इसको और simplify करना है.
Do you think you can? Like you have 4 outside. Do you need to break it down somehow?
I mean, there's 4 inside as well. I can easily divide it.
Yeah, so just divide it.
So then is the final answer just 2 outside and inside there's just 3?
Yep. So this becomes 2 power 4 times 3. The 4 divides, you're left with just 2 power 1 and 3.
सर मैं अपना इंटरनेट जरा स्टेबल करने की कोशिश कर रहा हूँ थोड़ा और टाइम.
Okay. And Ahmed, what about you?
Yeah, sir, for the most part.
Okay. All right. Do you need another problem for this or should I go on?
We could try one more.
Okay.
So the answer is 5 outside and 2 cube inside.
You can further break it down.
So then the answer is going to be 5 outside and then 2 raised to the power 2 into 2 raised to the power 1 inside.
So now 5 outside and 2 outside, that wouldn't they multiply? They give you 10. So basically, I know what 200 is. 200 is, I can think of it as 25 times 8. I could also think of it as 100 times 2, and 100 is 10 times 10. So I could do that. In fact, if I do that, that's the easiest one because I can just say 100 times 2. And what is 100? 100 is 10 squared. So that leaves me with, I can break this down. So this becomes 10 power 1 and there I have 10 square root 2 on the outside. But if I don't want to do that, if I want to work with some other numbers, for example, if I pick 25 times 8, it's my choice, but I will still end up with this answer. So 25 is 5 squared and 8 is 2 cubed. And I know that I can further break down cube into 2 squared and 2 power 1. And now what does this give me? This divides give me 5, this divides give me 2, and this divides, but this can't be divided. So there you go. So 10 squared 2 is my final answer again. Okay. So that's how you do surds. Any questions on this? All right.
I didn't get these that much.
I'm sorry?
I didn't get these that well, especially this last one.
So, okay. So I'll basically, the idea is that if I have a number here, any number here, let's suppose I have 3 here, and inside I have 5 power 7 times 2 power 4 times 3 power 2, then what I have to do is I have to break these powers into chunks that are divisible by 3. I have to break it in a way that the numbers are divided by 3. So this 7, I can break it into 5 power 6 and 5 power 1. This 4, I can break it into 2 power 3 and 2 power 1. Why? Because there is at least one number that I can divide by 3. And this I can't break it that way because no matter how I break 2, it doesn't divide by 3. So now what I do is I divide all the numbers by 3 that I can. So when I divide this by 3, I get 5 squared. I write it without the square root sign because I've divided it. I can't do it with this. It stays inside. I can do it with this. So 2 power 3 becomes 2 power 1 because I'm dividing by 3. This stays inside. This stays inside. Okay. So now my answer is going to be 25 times 2 is 50, 50 cube root, 5 times 2 is 10, 10 times 9 is 90, 50 cube root 90. That's my answer.
So for the second step where you broke them down, couldn't you have done 5, 3 and then 5, 4 as well?
I could have, but then if I do 5, 3 and 5, 4, I can further break 4 into 5, 3 and 5, 1. So if I had done 6, that would have been the easiest, sharpest, fastest answer. Now, here's another question, and this is a question that is similar to the SAT questions. So this thing, if 4 square root 3 is equal to square root 3x, then find the value of x. So here's how I can do it. I know that 4 square root 3 is, can I write it as x times 3, which basically means that I have 4 square root 3 and square root x square root 3, right? I can, right?
I didn't get this. I don't get this, sir, now.
I'll start over. Do you understand the question?
Yeah.
Yeah. So we have 4 times square root 3 is equal to square root 3x. And I want to know what x is. Now, there are multiple ways of solving it. One way is the easiest way, that you have to make x a subject. Just take the square on both sides, which means this will cancel out. And I'm left with, what is square root of 4? 16. What is square root of 3? The square root cancels out with this square, leaves me just 3. But don't multiply them yet. And on this side, I have just 3x. Now I divide both sides by 3, and this 3 cancels this out. And I'm left with x equals to 16. That is one way of solving it.
Okay.
Let me try solving it in another way. 4 times square root 3 is equal to square root 3 of x. Okay, let me break this thing down. I'll write this as square root 3 times square root x. I can do that.
Yeah.
Now, this square root 3 on the right side and this square root 3 on the left side, they're the same. I can cancel them out, which gives me 4 is equal to square root of x.
And then you square both sides, and then you get x.
You can square both sides, or think about it. What is a number that if you take a square root, you get 4?
16.
16. Basically, that's what this question is. That x is a number whose square root is 4. So x is 16. I know right away.
Yeah. Okay.
Okay. Now there's another way, and this is the most complicated one. But if you're able to do it, you understand this topic perfectly. Now we know that we can bring numbers outside. Like when I had 5 power 6, I brought it outside and it became 5 power 3, right?
5.
That is because it should have been 5 power 3. I don't know why I wrote 5 power 2.
Yeah, I thought it was 5 2 as well.
Yeah. Similarly, 2 power 3, when I brought it outside, it became 2 power 1.
Yeah.
Because I'm dividing 3 by the numbers inside. Now, here's the thing. What if I wanted to move this 2 back into this?
You'd have to multiply it.
I'll have to multiply the power. Exactly. So let me try to use the same technique over here with 4. What if I want to move 4 inside? What will I have to do?
You'd have to
I'll have to
multiply
multiply
it.
power by 2, right?
Yeah.
Yeah. So that means I'll have to move it and it will become 4 squared. And there you go. You can compare them. X is 4 squared.
Oh, yeah, no. Okay. Okay.
Okay. So that's the level of skill we need to develop for this topic.
All right, sir. Got it.
All right. So here's an exercise. Let's try to solve it now. And then we will have some sad questions after this.